genitalia.
Yeah.
And that's a strange thing, and that's on TV now too. Good. That's a strange name for a restaurant, my opinion, right? Just saying. Did I send you home with homework last night, or did we go homework free? Good, we went homework free, so we took a little hiatus. Mm-hmm.
I'm going to a funeral. Is it okay if I leave math like 5 minutes early?
Of course,
Thank you.
of course.
No, Olivia, you are not allowed to leave math.
You are not allowed to pay respects, no, yes, please, by all means, by all means. I would feel like a rotten person.
Mom, this is why I said no.
No. The emperor says no. Oh gosh, I mean, we'll get started. Oh, some people, when you can play hypothetical games with them, when you like make something up and then they add to it and you add to it and then you come up with like this whole little fantasy world that a friend of mine and I play that game as well as anybody I've ever played that game with. And we were at Cedar Point and it related to an emperor saying yes or no, and that, like, it was like Big Brother with 1984 with an emperor, and then you'd go into judgment, and all you would see would be on a screen the emperor with his thumb like this, and he would either go up or down. Because back in the day, right, whenever the gladiators, that's how they did. Like, so the emperor says no. Oh no! And we were joking because we'd go on the roller coasters and we were like, is the emperor going to say yes or no? Is her head going to get chopped off while we're going to the roller coaster? Like, are we going to lose a limb because the emperor's mad at us? It was not a video game. It was funny at the time. I wish you could have been there. I wish you could meet the guy. Were you in the econ class whenever I showed the pictures that the roommates took at Sears? Oh gosh. Oh, that's Mike Barnes. That's the guy. He and his roommates went to Sears to take family photos. He and the four roommates. He works at Lockheed Martin, which Lockheed Martin designs satellite systems for air traffic control. So he and his 4 engineering buddies went to Sears to take family portraits, and they took where they're all laying on the ground, head, from above. And then they took ones that are looking over the shoulder like this, and they took the most awkward photos they could possibly take, and they dressed up in the craziest clothes. Yeah.
I saw this one online, and it was the worst family photos or whatever.
Mm-hmm.
And there was this one, and I don't even know how to describe it. I don't remember what they were wearing. They were wearing really awkward outfits. And they were laying on top of each other. The first person was laying down with their legs up and out like this, and then the second person was laying down on top of them with their legs less far apart, and then there was a baby on the top just sitting there.
That's so weird.
I showed it to my brother and he was like, "Oh my god."
Yeah, right.
What?
And you know
and
that the person,
spider,
the person taking the picture isn't telling them to do that. They're like, "We want this picture." You know, the people who are getting the picture taken. Moral of the story, the 4 roommates got a big poster-sized picture from Sears, framed it, and put it above their fireplace. So, you'd have to know the guys maybe, but it's funny. I think it's funny. Okay, parabolas. This is a conic section, and when you think of a parabola, what do you see in your mind? That's nice. Something that looks like this. Now, the normal parabola starts at the origin, and the normal parabola equation is y equals x squared. Remember how we did circles? Just to keep this straight, this is our parabola equation. Y equals x squared. Does anybody remember the circle equation, the base circle equation? X squared plus y squared equals r squared. So keep these straight because there are 4 conic sections. There are 4 formulas. You're going to need to know these. These are fundamental to being an advanced mathematician. There's a professor at IPFW who is one of their most renowned researchers. His name is Dr. Pan. If you took a class from him, you would realize just how many words could be said in 1 minute. He talks so fast. So he's manic. I mean, he's hyper. Anyways, his entire body of research is in conic sections. And he solved a hyperbolic equation that was famous. And he is now famous as a result. And it's possibly going to get published in the American Mathematical Society Journal. And what I'm telling you is, if the big time mathematicians are studying this stuff, it's important, we need to know it. So we need to know the difference between a circle and a parabola. Now, we know that we can play the shift game. We played the shift game a lot yesterday, right? We played the shift game with cosine and sine graphs. Remember how the shift game works, right? Because if I sub in, if I make an equation like this, y plus 2 equals x minus 3 quantity squared. That's a parabola that's been shifted. Notice the parabola equation is normally y equals x squared, and now the equation is y plus 2 equals x minus 3 squared. Let me solve that for y. So it looks like this. Now, what does plugging in x minus 3 for x do? It moves it to the right 3. And now think about this. Remember with your sine graphs, if you have a function and you want your function to move up or down, all you do is you just plop a plus or minus on the end, right? So you could think about it as subbing in a y plus 2, and that means you're going down 2. But you could also think about it as, I have this equation with 2 taken away, so everything's going to come down 2. So that minus 2 is going to bring everything down 2. It's a parabola, right 3, down 2. So how would I draw that? Right 3, down 2. There's my parabola. Your graphs do not have to be precise. What has to be precise is where the vertex of your parabola is. That has to be very precise. And you have to make sure your parabola opens up. It cannot open sideways. Okay? If you have your parabola open like this, you have failed the function test. And if you fail the function test, now you have an unreliable function that mathematicians don't like. Push the button on the microwave, sometimes one thing happens, sometimes another thing happens. That's what you get if you draw parabolas that aren't nice, use, looking up, or possibly going down. Because remember, when we have the normal sine graph, and then we take the negative and just put it in front, what's it do? Take everything positive and turn it negative, takes everything negative and turn it positive. What would be the difference between y equals x squared, which we know is that guy, and y equals negative x squared? Jordan? Reflect, wow. Could that have been said any more properly? It's reflected about the x-axis, because everything that's positive becomes negative. That 0 point is still 0, but when you have a negative sign in front of your x, that basically means your parabola is going to open down. So, base equation for the parabola. Can you shift a parabola? Yeah, you can shift any graph. Oh, you guys, this is going to blow your mind. If we have time at the end, I'm going to blow your mind. If we have time at the end. Your mind will be blown. But just wait for it until that comes. But base equation for the parabola, can you shift? Yes, because you can shift any graph. Can you flip it? Sure, because you can take any graph and make it negative. So if you see a negative in front of the x, whoop, upside down parabola. I could see this same equation here. Let me do this one. The y equals x minus 3 squared minus 2. Notice how it's exactly the same as the one that I drew over here? I'm going to change it now and put a negative in front of that. What's it going to do? Flip it upside down. So, you're still going to go right 3, you're still going to go down 2, but your parabola is going to be an n instead of a u. Kosher? Okay, now, does anyone remember how to complete the square? Because if you're going to graph parabolas, you've got to know how to complete the square. Let's remember how to complete the square in the event that we've possibly forgotten. Okay? Or in the event that it's possibly got a little rust on it. Because completing the square is necessary to graphing parabolas. So let's review complete the square. And let's start by doing some basic squares, like x plus 2 times x plus 2, x minus 3 times x minus 3. Notice that's a square, right, because it's something times itself. And I'll do x minus 6, x minus 6. I think 3 will be enough for us because we've seen this before, and hopefully it's relatively familiar. Foil this guy. The top one, you're going to get x squared plus 2x plus 2x. That's plus 4x plus 4. The last guy, or, well, the middle guy. Let's do these in order. The middle guy. Foil x squared minus 3x minus 3x. That's minus 6x plus 9. And the x minus 6 times itself. Foil x squared minus 6x minus 6x. That's minus 12x and plus 36. Now, there is a relationship between the middle term and the final term. To where if I gave you something like x squared plus 10x, you should be able to produce a number that would plop on the end that would make that a square. Now, is there a relationship between the middle number that would allow you to get to the last number? Skylar?
When the numbers are added, it's the middle number when they're multiplied.
Yes. Now, if I just gave you this 4, could you produce the other 4?
Yeah.
If I just gave you the negative 6, could you produce the 9? What you said is not incorrect. I'm just asking the question more clearly, because I didn't ask the question clearly, if I got an answer like that, because that's on me. If I just gave you the negative 12, could you give me the 36? Kramer, you're saying yes. How would you do it?
You divide the middle term by 2.
Okay, so we take half the middle one, and then what do you do with half the
And then
middle?
you square the middle.
Does this sound familiar?
Yeah.
Half the middle one and square it. That's how you complete the square. What's half of 4? 2. Square it.
4,
What's half of negative 6?
3,
Negative 3. Square it.
9,
What's half of negative 12?
36.
And the neat thing about this is half of negative 12 is negative 6. X minus 6 is how you write the square. Half of negative 6 is negative 3. That's how you write the square. Half of positive 4 is positive 2. And it's x plus 2 times x plus 2. Woohoo, right? So, if I gave you x squared plus 10x, half the middle one is square it, add 25. And when you do, you know that's x plus 5 squared. Why plus 5? Because that's what half the middle one is. And if you don't believe it, foil it. How do we complete the square? Half the middle one and square it. Do you feel refreshed on that? Because we're going to put that into practice here on graphing a parabola. Let's graph some parabolas. Do-do-do. Do-do-do-do. That's the universal erasing 2/3 of the board user. Okay. Complete the square to graph y equals x squared minus 4x plus 2. Now, if you had a lot of time on your hands, you could make a big XY table, and you could make a graph that way. I'm going to show you, I hope, that by completing the square, we can come up with a graph a lot quicker. Now, when you look at the completing the square, here's how we're going to do it. We're gonna leave that plus 2 alone. We're not gonna mess with him. What we're gonna do though is look at those first 2 terms, and we're gonna find out what we need to do to complete the square. So, we take half the middle one, and square it. So, in other words, we have to do, now, think about this for a second.
No,
This is an equation. I'm about to write plus 4 on the right side.
I could do it on the other side.
I better do it on the other side too, or else I just made a mistake. Because if I add 4 to one side and not the other side, I don't have equality. This is an equation. I want to make sure I keep equality. So, I have y plus 4 on the right. And now, the purpose of completing the square was to be able to rewrite it as a square. X minus 2 squared. Y minus 2? Minus 2 was our magic number that made our square. We still have that plus 2 at the end, just chilling. Now, how do we normally solve equations before we graph them? We solve for y, right? So let's subtract that 4 away, and we'll get y equals x minus 2 squared minus 2. That looks very parabola-like, doesn't it? It's just been shifted. What does the x minus 2 do to our parabola? That shifts us how? Right? 2. And what does taking everything and subtracting 2 do to it?
Take it down.
Taking it down. Taking it down, taking it low. Dropping it like it's hot. Okay. It's a parabola.
Really?
Yeah.
How does it?
So, what does our parabola look like? We go right 2. We go down 2. Is this an upward opening parabola or a downward opening parabola? Upward. There it is. Now, I'm going to argue that the process of completing the square was relatively harmless. And if you wanted to make a picture that accurate with x, y, you're gonna, no, you just don't want to do that. It's tedious. It feels like you're a machine, and it's boring. This is not boring. Well, this is less boring. This at least feels like you're doing something. Whereas when you're just plugging it in, getting something out and plugging it in, getting something out and plugging in and getting something out, you're like, man, I wish I could just program a computer to do this for me, right? Well, here, you can do it all on your own. What we just did right now, by the way, what we just did, starting from an equation and graphing a parabola by hand, I would guess 1 out of 10,000 high school students can do. That's a guess. It seems unreasonable, but that's a guess. And the reason is because graphing calculators were created. So you could just plug that in the graphing calculator and get the graph, and then say, oh, I know how to do it. No, you don't. If you have to use the calculator to do it, you don't know it. Like, yeah, right, exactly. Do you think Dr. Pan at IPFW came up with his big formula from a calculator? No. Because if he could come up with a calculator, like, you could too. And that's not the way things work. That's not the way math works. Let's do another. Complete the square to graph. Y equals negative x squared minus 6x minus 8. I mean, I'll tell you right now, when you look at this, you're just like, oh, so many negative signs. Question, do you want to complete the square with negative signs? No. Where do you complete the square? On that x squared side, right? Do you want to deal with the negative? When we talked about completing the square, did we ever involve a negative? No. So here's what we're going to do. We're going to first, if you ever encounter an x squared with a negative in front of it, multiply both sides by -1. Make that y negative in the meantime, so that while we complete our square, we're dealing with positive numbers. Right? Just shift that problem on the back burner for now, and then we'll deal with that problem later. Because it's easy to multiply by -1. Now, at this point, we got to complete the square. So we take our x squared plus 6x, leave a blank, And then we got that +8 chilling. Half the middle one is 3, and specifically a +3, and then we're going to square it, and when we do, that means you have to put a +9. Well, look what we just did. We just added 9 to the right side of the equation. So if we add 9 to the right, we best be adding 9 to the left. Else we just threw off the balance. This is an equation, both sides are supposed to be equal. So add 9 to one side, add 9 to the other. Now, on the one side, we have minus y plus 9 equals, we just completed a square. Write it as the square. X, what squared? X plus 3 squared. And we still got that +8. Now, how do we solve equations to look at them to graph? We tend to solve them for y. Like, remember back in the day when you first graphed, right? You tend to solve for y. So, let's solve this out for y. Subtract 9 from both sides. -1. But that's not y, is it? That's a -y. Remember that problem that we put on the back burner? Now that's the only thing left. So what do we have to do? Just multiply both sides by -1. So the y becomes positive, this quantity becomes negative, and the -1 becomes a +1. Believe me, that's easier than trying to deal with the negative sign any other way. Basically, throw it to the other side, and then bring it back in. Now, questions on what we did there with the negative sign? Yes?
Well, I just left the negative sign, but then I repeated it.
You just left the negative
Like,
sign.
I kept the negative sign in, like, the equation.
Yeah, because see, here's what you would have to do. You have to factor out the negative sign, and then write it like this. And then when you write the +9, what you really did is subtracted 9. Because the negative is associated with everything inside the parenthesis. The 9's inside the parenthesis. So while you wrote a +9, what you actually did was subtract 9. Do you see where that comes from? So, my strong recommendation is put the negative on the back burner, and then just fix it at the end. Can we graph this? What does the x plus 3 do? Left 3. What does the +1 tacked on the end do? Picks everything up 1, so we're raising the roof now. And what does that minus sign in front do? Whoop, it's a downward parabola. So I think we can make a graph of this. Left 3, up 1, downward parabola. Yippee. I'm telling you, 1 out of 10,000, maybe. It's probably 1 out of 100,000. Just not taught anymore, and it's silly. Because when Dr. Pan solves his hyperbolic equations, he does it on paper. And you know how he solved it, by the way? I'll just tell you the story. He was in China, because he's also a professor in China as well as in America. He teaches in America during the regular school year here, and then in the summers he is a professor over at a university in China. Yeah, how cool is that, right? And he's giving a lecture in China, and while he's talking about something to undergraduate students, he realizes a connection between what he was talking about and what he's been trying to discover. And he knew that he had it. And he said he lost track of what day of the week it was every day. Because for the next 3 months, he spent 12 hours a day writing out the details. 158 pages published of documentation. And this is a wonderful, but think about it, he's in his lecture, and he made the idea connection, and he knew it worked. He had that aha moment. 3 months, 12 hours a day, every day, 7 days a week. Whew, right? Success comes at a price, as I'm spitting on you, right? Man, it's hard work. Okay, so let me give you some homework problems, and then if we have time, I can blow your mind. We may have some time for me to blow your mind, but we'll see. I may have already blown your mind with the Dr. Pan thing. Just to think that, oh, I got it figured out 3 months later. Right. 54.
That's crazy.
Yeah. 8 and 9. He later went to a lecture with one of the most famous calculus professors in the world. and the calculus professor was talking about this famous result, and it was his. Imagine how cool that would be. Like, imagine if Peter Martin was talking about this, like, epically wonderful performance, and it was you, and you were in the audience, and you'd be like, that's right. That would be such an awesome
Mid
feeling.
background, nailed it.
He was he came up with the idea last year. He was promoted to distinguished professor at IPFW like the same year. Because when you do stuff that's that good, you get remembered. It's pretty awesome. And if you could, you should go online, look up Dr. Pan when he teaches, and just sit in his class. Like, you should just go over there whenever he teaches. Because it's in the evening, you just sit there and just like, oh man, it's so fast. And and he plays basketball down at the IBFW because he's like 6'2".
Oh.
So it's unusual for a Chinese man to be 6'2" for one, because the gene pool in China tends to be short. But he goes over there and just plays basketball with like the college students. Like, how cool is that, right? Like, if you were a professor and you like playing basketball, you're like, hey, I don't care, I'm gonna play with the kids. Probably balls them.
I know.
Probably like crossing over, dunking. And I got he dunks, but anyways. Let's also do 15 through 18. And let's also do 21, 22, and this is going to be one of the longest assignments of the year. $30. So, you have no chem homework, I know that for sure, you just purged your mind this morning, so this is still reasonable. And it'll be good practice because we're in a position right now. Would you rather have your test in this class next Tuesday, Wednesday, Thursday, or Friday? I can work around any day. Tuesday, Wednesday, Thursday, or Friday. Does anybody have a preference?
Tuesday.
I say not Friday because we have a lit quiz.
Not Friday because we have a lit quiz Friday,
Those
so
are easy.
Tuesday, Wednesday. But still, yeah, why not? Why not, right? Okay.
I don't like Wednesday because I mean, these people like forever late that night.
Should we do it Tuesday?
Like Thursday.
Oh my
I
God.
mean, you're at EDC
I'm willing
on
to make an
Wednesday?
executive decision.
No, Tuesday night.
Tuesday, okay.
So then I would,
So you would prefer to not be Wednesday?
right.
Don't care?
Tuesday?
Tuesday? Don't care? Just not Friday? So we have Tuesday, not Wednesday.
I don't care.
Okay, so we'll just go Tuesday. Advance math. Unfortunately, this will be our first test of the year. Yeah, you gotta go. Unfortunately, this will be our first test of the year. I say unfortunately because it's been so long. Or did we have a quiz? We had a quiz?
Quiz.
Okay, so we're, okay. So this actually isn't too bad. This isn't too bad. As I see it, can I borrow your pen for a second? Thank you. 54 is down, so as I see it, we basically have half of section 56 and then section 57 to discuss. And that will be our job for the next 2 days, and then we'll take our tests, and I'll get you plenty of review information before the weekend.